What's up, guys? There's a second video of today because I missed yesterday. We just did the maximum element in a sliding window. Surprisingly difficult. It took me a long time. Um, so the cheese is to actually use DQ. And by using DQ, I am pushing the element into. Now using max heap is the one that I understand most, but DQ is like keeping the Q in a decreasing order by popping everything that is smaller before appending the current element, right? Yeah, which is kind of like a max heap in a way. So I will push it. Using a max heap seems to make the most sense anyways. So whatever. So yeah, um, I have a Windows machine here, super old, um, Samsung laptop. It is pretty cool. Um, yeah, so I'm gonna use this to solve phase two. Phase one was what was it? Let me see. Phase one was border relations with Canada have never been better. Interesting. So yeah, let's go for phase two now. So I can see, um, um, so I see that the code is pretty similar. Like if you object dumped it in a Mac versus in an x86 machine. I did it in Linux. Um, whatever. But let's do it. So here you're making space, right? You're allocating memory. You're moving the stack pointer. And then here, I'm assuming you're just moving all the arguments into it. Particularly this, right? You're moving RSP, what is pointing to, into RSI, which is kind of similar to what we're doing here, right? Um, so, because what we did just now is we read what was in this address, right? And that was the solution. So if we go run, type in a random string. Oh shoot. Ah, okay. So I need to add the breakpoint. No breakpoints. Okay, cool. You can't see what I'm doing on my Linux computer because this computer is literally 10 years old. Um, and I don't think it'll handle the external display very well. So I'd rather just not do that. So what we're gonna be doing is just this, right? I'm just gonna check the assembly in on my MacBook, on my modern machine, and then I'm actually gonna be coding in this old, ancient Samsung laptop. So what I'm gonna do first is I'm gonna put the breakpoint in 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 read six numbers, right? Because why would I want to put this in? Because I would want to know, because this, you're moving whatever is in RSP into RSI, right? And then you would use RSI as an argument to shove it into read six numbers. And then if we look at read six numbers, here we go. So again, you're moving the stack pointer, so you're allocating memory, and then it's just a bunch of stuff, right? So we go back to phase two. I suspect, what I suspect is that, let me upload my video first real quick. Stay 74. And that was a difficult ass question. That was not too difficult. I just needed to know the data structure, right? And I didn't know that data structure, unfortunately, which is the double-ended Q, the mono something Q. What was it called? Mono something Q. What was it called? Monotonic Q. Yeah, monotonic Q. Cool. Um, cool. Okay, the video is in progress now, so let's continue. Yeah, so what are we looking for now? Phase two, right? So I want to set the breakpoint here. So when it will stop at this entry. So when I'm in this, I can just read what's in RSI, right? Cool. So what I want to do is I'm going to run the program, and then I'm going to type in a random ass string, right? Which is, I cannot type the random ass string now. I'll type this string because if I didn't set a breakpoint between at phase one, right? So right now I'm putting in a string, and then that string will be run through phase one, and then if phase one fails, they'll just jump to return, right? Let's just try that to see if it's true. It is. So the bomb has blown up, right? So we have to run it again. Um, and then I will write border relations with Canada have never been better. Boom. Now phase one is diffused. And then I will write a random ass string in there, and then it will be read into here, I believe. Let's try. I'll put in a random string here. Now I'm at breakpoint one and read six numbers, right? And then what I want to do is I want to read what's in RSI, right? And to do that, um, I'll have to figure out what RSP is here. So RSP will be 400 EFC, and then I will subtract 28 from this, right? Which should be 400, and then subtract hex 28, right? So F minus 2 is ED, right? And then C minus 8 would be uh C is 12 minus 8, so it should be 4, right? So as long as I read 400 ED4, I should have something, right? So let's go with, and then 400 ED4. It's empty. Interesting. Okay. Okay. I call this, then if it's equals, then I'll jump. If it's not equals, then it explodes, right? So what would this be? Subtracts RSP goes to 28, and then it moves whatever's in RSP into RSI. And then whatever's in RSI will be moved to RDX. And it will calculate a bunch of shit. What is this call Q thing? Um, ja. Read 6 numbers. Read six numbers. How does it read six numbers? Okay, ED4 is definitely correct. And then I'm calling read six numbers. And if I call read six numbers and then I compare, and then if it's equals, then I'll jump. So read six numbers has to return true. What is this 4025C3? What is that address? DDD, DDD. So is this saying as long as it's some random number, it'll be fine? Something, 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 something. Would that be it? It's not. Okay, the bomb has blown up. This right here is something, 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 something. Hmm. Move these numbers into ESI. Whatever those numbers are. Okay, so how do I step? Hmm. Hmm. Okay. Look, next one will be 6B. Next one will be 70, 70 done, 74 done, 78 done, 7C done, 48 done, 85 done. And then now I want to see these. EAX, FFDE40. Hmm? Cannot access. It returns 0. Oh. Changed a bunch of shit. This is about F. Compare. Boom. Greater. Jump. So I'll say, and the next one is going to call. Explode. Right. It might be an actual number here. Right. It could be an actual number here. Okay, cool. I think I have to do some math then. It's ED4, right? I think it's 400 ED4. That's what we calculated just now. Yep, 400 ED4. Let's uh write that down, right? So that's what's in RSI right now. And then I want to go to what was it? Right? Okay. So I've subtracted, allocated the memory, and then I've moved the entire RSI into RDX. So what RDX has right now is this. You know what RSI has right now is also this, right? It's also ED4. And now I want to calculate the effective address of 4 times RSI and then put it into RCX. Um, no, so it's RSI plus 4, right? That's what it means. So RSI plus 4 will be ED8, right? Um, I will see what ED8 is. Okay, so it's a bunch of random shit. Put into RCX. EF8. Let's see EF8 then. Am I tripping? Take these two. Subtracted RSP. I moved RSP into RSI, right? I don't think that's wrong. And then I call this. So I saved all of this. So I subtracted 18 from the RSP. And then I moved whatever is in RSI into RDX. And then I'm calculating effective address of memory location RSI plus 4, which is ED8. And then I also have that, and then I'm moving whatever is in that into A plus RSP. So I'm allocating more stuff. I see a couple of things here, right? I see RCX, I see RAX. This is one. This is probably one as well, right? This is probably one. This is probably one. So let me see what these are, right? ED4 plus, let's say 8. So it will be ED12, EDB, right? It's also a bunch of this. What is that? I'm reading whatever's in that thing and it's not making a lot of sense. It's really not making a lot of sense though. Ta bot execute, ta say execute, say bot link. Okay, no, 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 no. Okay, so the next instruction will be 480, right? But now I will check what's in those. ED8? No, it's EDB. No, what's in RSI? Let's just look at what's in RSI, right? RSI is this. So I will have to read len x, tut f, ff, 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 de 38. Oh, oh, okay. So R9 has this, maybe. R8 has what? No, this is R8. R9 is plus C. So it's the same thing. Hmm. Why? What's in here? I'm seeing a bunch of random shit, man. RAX? What about RAX? Would those be the numbers? Doesn't seem like it. Say bottling, right? Say bottling is the next thing to be executed. Executes 480. So now this is in RSI. 4203971. So what if I read that now? Right, that's what's leading me to think it's six numbers. And then Rx will be set to zero. The next um instruction, right? hmm This is what we're looking at. The RSI is what we're looking at. Yep. And then I call this whatever this is. Don't know what that does. Just some things. And I'll compare five. Okay, let's do the next instruction as well. Boom, it changes a bunch of shit. Right? And Rx is one, but then it should be five. It should somehow be greater than one. What should those six numbers be? Okay, I've killed the process. Let's run it. Border relations with Canada have never been better. Cool. What if I just do this? No. Am I a dumbass or what? Like, and whatever is an RSP, right? I'll read the six numbers. But read six numbers in itself, I will explode the bomb. Okay, so I'm guessing it has to have at least six numbers, right? It should be six numbers. And then where I'm exploding would be like after this. So I'm jumping to 400 F30. Where's F30? Oh, no. Okay, there's some sort of loop here. I'll jump to 30. I'll calculate. I'll calculate. And then unconditionally jump to here. Move L. Jump to 25. Add 4. Compare. Jump not. If it's not equals. I'll jump to 17. I hit 25 again. It's not equals. And if it is equals, then I'll jump to here. Okay, I'm getting more clarity now. I am getting more clarity now. Jump not equals, it'll move back here. And then it has to keep equaling. It's some sort of loop. It has to be some sort of loop, but what is the loop? So I read the six numbers. Jump equals to F30. Calculate what RSP is pointing at. Let's add a breakpoint at say ling f ling a, right? Break line samba. Hooks up. What? Why can't I do addresses then? Oh, I have to. Hmm. No, but I couldn't get to even read six numbers though, right? Because the bomb's exploding. Read six numbers. Then does it have to be where? Okay, okay, chill. So if I go run, order, right? Does it have to be more than six numbers? Okay, so it has to be more than six numbers, I think. Is it? Let's do six numbers. What the fuck?
識一識個冷鍵先啦，
咁啊，
因為上面有噪音啊，我叫人出嚟睇嘅，熄一熄先唔會好熱啫。
so Oh my God, what the fuck? Okay. Hmm. Honestly, I'm lost as fuck. I have to look at the answer, man. What the fuck? I've been stuck here for so long. Okay, let's see. Dun-dun-dun. Yep, that's the first one. Bruh. It just says, okay, okay, fine, fine, fine. I looked at that tutorial, and that tutorial said nothing. So I believe it is God's plan for us to not to struggle a bit with this. Okay.
That's phase two.
I'm putting in whatever's below. Really, I'm moving ED4 in there. Right. And then 2E, Reg, General. So what's in RSI right now? What the fuck? O2 has been executed. So what RSI would have now would be nothing. Would literally be nothing. What the fuck? Numbers could be R bot Argyle. I'm also in ES I, so R psi, some RX is 6 maybe? I don't know how to do this. Uh-huh. So you're saving this. Yep. Allocated memory. What does this mean? Stack frame. Yep. Allocating stack frame. Mm-hmm. Yep. This is the read six numbers, right?搞咩佢？
咩話？
搞咩？
有啲噪音喺上面，
上面
我唔知係咪佢哋個冷氣啊定咩？佢都
我即係佢做到你啊，
嚇，
佢做到你。
我估係上邊咯，
哦
因為啲聲其實好低頻嘅噪音啊，即
哦，
係啲嗰啲
明白
啲出去
明白，
走廊出邊都聽到㗎，
咁啲。
所以我要同佢講啊，因為唔係
嗯
之前試過，但係而
嗯
家再出現啊嘛，我梗係同佢
嗯
講啦，咁啊遲
，OK，
啲揾唔到喎。
走走走。寄存器 is a memory, and two of them are in the stack, and two of them are in the registers. 寄存器 are the registers, right? RSP 與這個中的 RSI 相等，所以把所有參數存在 RSI 之前嘅位置的目的係喺返回 phase two 之後，phase two function 之後能夠直接利用 phase two 嘅 base pointer 訪問呢六個數，OK？ Fuck? What the fuck, dude? You're moving this pointer, stack pointer to RSI. Calling function as parameter to call function read six numbers. We have to input six numbers, right? That part I understand. 這裡 move RSP RSI 的目的是保存 caller the top of the stack frame. You're preserving the base pointer, maybe? Yeah. So now reverse and read six numbers. Now this is the stack, right? So there's the bottom. Now I'm growing downwards. RSP, RSI. And then now this will be read six numbers, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these. Okay, so I subtract 0x18 RSP. Now I'm here. And then move RSI into RDX. Yeah, I'm pouring here. And then 0 plus R psi plus 4, it will be RCX. So RCX points to R psi plus 4. R psi plus 14, I'll put into RAX. Move whatever's in RX into RSP plus 8. RSP plus 8. So X 14 plus R psi. And then R psi plus 10 will be in RAX. And then R psi plus 10 will be in RSP. R psi plus C will be in R9.
What the fuck?
I don't understand. What the fuck? How am I ever gonna do phase 3, 4, 5, 6? Walk me through this, fam.
Hello everyone. Third video on the binary bomb. In this video, we're going to go over the second phase. So let's just get started. All right. Now, if you remember, our input for the first phase is pretty long, and we're not going to want to type in that every single time we run the program. So what you're going to want to do is a text editor. There's a couple of text editors out there. There's Nano, there's VI, there's Emacs. Um, VI is pretty cool because it's color coded. I've never really used Emacs before. Nano's pretty simple, so let's just use Nano. So you're going to want to type in Nano. Okay, here's your text editor. And let's just type in the input for first phase, which was I was trying to give Tina Fey, more material. Yeah, there you go, with period. So make sure you get that right. Type in Control X to exit. That's going to ask you if you want to save. Uh, type in Y for yes, and let's save it as answers.txt. Now I already have a file called, or I already have a file named answers.txt, so it's probably going to ask me if I want to overwrite. Let's just type in yes. Okay, cool. Type in ls. You're going to see it's right there. Answers.txt. Right, so let's get to it. Clear all of this. Just type in clear and enter. Okay, now let's use GDB, which is our debugger, and you type in the name of your bomb. In this case, the name of my bomb is just bomb. Type in enter. All right. Now we're going to want to set a breakpoint at phase 2. So just type in B phase 2, and then we're going to want to run the program. However, we're going to want to run the program with our answers.txt file. So you type in r answers.txt, you hit enter, and as you can see, here's the welcome string, and here's the phase 1 fuse string. Okay, that way we don't have to type in, I was trying to give Tina Fey my material. That way we don't have to type that every single time we use it. That's good. So now, right now, it's asking us for um in second input or
Holy moly.
We can circle back on this, take this offline. We don't want to boil the ocean here. What are you working on there?
Oh, I'm just working on my assembly assignment.
Assembly, huh? And how exactly is that going to help you on the job?
Hey, you're supposed to pay for it.
Oh, I'm so sorry.
Yeah.
I thought this was I thought this was free. I'll pay off.
Well, hey man, how did you do on the calculator?
Oh, that doesn't matter. But I'm gonna have a return off.
Dude, you're not gonna graduate.
Welcome back.
All right, let's figure this out.
Answer for the second phase, right? So we don't really know what it is, so let's just type I like bacon, okay? All right, so now we type in this as, which disassembles the assembly code. Now it's going to do a bunch of stuff here, like it's going to subtract some stuff, it's going to load a couple of stuff into EAX, move things around. Okay, we don't really care too much about that. What we want to do is we want to look at the compare statements. And, oh wait, before we get to the compare statement, there's a function here called read six numbers. I don't want to take too long on this, but if you go to next instruction several times, we're eventually going to get to read six numbers. Okay. Now, if we step into it, right, you're going to see right here that we're now in the read six numbers function.
Mm-hmm.
Okay, so let's just skip all of this. Do that. Oops. You do that by typing in until asterisk and then the address of wherever it is you want to go. So let's just type that one in because we want to see if we really do need six numbers for our input. Okay. Remember our input right now is I like bacon, which is just, it's a string. So let's type that in. Let's disassemble one more time. Okay. Now there's a compare statement here where it compares EAX at 5. Okay. EAX is greater than 5, then it's going to jump to 77, which but where it'll then just leave the function. If our input is incorrect, it's just going to call this explode bomb function. Okay, so let's see if it does that. Yep, here we go. It's in the explode bomb function. So let's just quit. All right, and let's clear all that. All right, so we know that what we need are 6 numbers and no characters. Okay, so let's just type in GDB one more time. Set a breakpoint on phase 2.
Mm-hmm.
Now we're going to want to run again the answers.txt file. Okay, welcome to my phase 1 fused. All right, now it's going to ask us for the input for the second phase. So let's just type in 6 numbers. Just type in 1 through 6. I wouldn't type in 6 ones because then when you're looking at the compare statements, you don't know which digit is which. That makes sense, or which input is which. So you're not going to know if it's comparing this one to this one. You know what I mean? Or if it's 6 2s, you don't know if it's going to compare this 2 to this 2. So I just recommend typing in 1 through 6. So once you do that, you're going to want to type in enter. Okay, let's disassemble the code. Again, it's going to subtract some stuff there. It's going to load stuff, EAX, blah, blah, blah. All right. Now let's just skip all the way to this compare statement down here. Everything goes as planned. Then it should go into read 6 numbers and without calling that a explode bomb function. So let's just see if it does that. Let's go ahead and type in until. And it did. It's comparing a couple of things here. It's comparing something to 1. Okay, and I'm going to tell you right now that the first input or the first digit should be 1. And in our input, our input is 1, so that's right. Here. Okay. Now we're going to go to next instruction, next instruction. It's going to load a couple of things into EVX. It's going to load some stuff for ESI. Don't worry about any of that. Notice how we skipped the explode bomb. Okay, so what happened here was it was comparing something to 1, and if this was equal to, okay, again, if it was equal to 1, then it'll jump straight to 37. So that's a big clue right there. Our first input has to be 1. Okay, so let's just continue. So next instruction, next instruction, um, next instruction. There's a line of code right here that's very interesting. It's adding EAX to itself. Adding EAX. Itself. So you're going to want to type in IR, which stands for info register. Here we get all the information on all the registers. So here we can see that EAX is equal to 1. So when it adds 1 to 1 or EAX to EAX, it's going to give you 2. And it's going to compare EBX, which is, let's see what EBX is. EBX is some weird.
Oh my God. What is EAX? It's 2. Now it explodes. Compare. Code 17. RBX and RBP, RBX, RBP, and they're not equals. I'll jump to F17. One A. C. Four. So 1, 2, 4. I want to say 17, right? That goes into the loop. 1A. First 1A. Second 1A. 25. Add 4. Compare. Not equals, and then now I'm back at 17. 17. Execute. 1A. Execute. And then now I want to look. It's 8. Next one would be what seems to be 8. What seems to be 16. What seems to be 32, right? FE. Next time I see, yep, okay. I'm so clear. And then I run. This should be it. Please tell me, oh, wait. Delete breakpoints. Yes. Clear this. And then what I want to do is simply R answers txt. That's number 2. Oh my God. Okay. Number 2 is done. Okay, let's go to number 3. Cool. I guess I can do number 3 as well, and then I'll sleep. Let's look at phase 3. Phase 3. Let's see. I finished that. Some more complex code will confuse people. All right, fine. So phase 3, let's see. So again, moving the pointer. Oh wow, okay. So, okay. This seems to all come back to FBE, which is where FBE here. Compare. And if it's equals, it'll come back. to FC9. So these are the two key ones, right? I'll go to FC9. And I'll jump to FBE. And then I'll compare. And then if it's equals, then I'll jump to here and then it's just done. So I'll compare, move to this, compare, done. Move to there, compare, done. Okay, these are all like immediates, which is very interesting. So I calculate stack pointer store in RCX. I calculate, okay, which is very weird. And then move this into ESI, then move L into 0, and then do some shit. And then I will compare 1 with AX. Okay, very interesting. So let's go some random shit, right? Okay, straight up broke down. Okay, so let's set a breakpoint at there first. Boom. And then I'll give some random stuff. Okay, and then now I'm in F43. So if I step 1, it will be moving the pointer. Oh, sorry, moving the pointer. Storing some shit. Moving that into ESI. 0 will be in EAX. And then I'll call some shit. And then if EAX is greater than 1, then I'll jump. Okay. If AX is greater than 1, then I'll jump to F6A. And then I'll compare 7 with what is given here. And if it's above, then I'll go to FAD. FAD. If it's above 7, it'll explode. If not, I'll move down to AX. Jump Q. I forgot what jump Q means. Shit. Jump. And then move L. Compare EX and 1. I'm guessing the first thing will be 1 then. Just guess. Just a random guess, right? Let's go. All right, 1, 2, 3, 4, 5, 6. Let's go 1, 2, 3, 4, 5, 6. Right? F43, 47, 40, for C, 47. 47 is done. 4C is done. 51 is done. 56 is done. 5B is also complete. Oh, what? What? Hold on. Oh, did it already? What? Oh, the bomb is blown up over the mile. Wait. Okay, wait. Let me quit it first. And then let me do this. And then let me run with this, if possible. What's going on? So run TUI is doable. Okay, whatever. Um, and then run answers. Okay, cool. And then I want to step through it, right? 43 is executed. What? Fuck. Mixed. Oh, NR deal. 43, 47, 4C, 51, 56, 5B, bunch of shit happens. 60, right? And then 63 executes. It goes to 65. It blows up because it's not bigger than 1. Okay. What if I go 2, 3, 4, 5, 6, 7? Right, that could work. Oops. What if I go 2, 4, 5, 6, 7? Right? Hmm. Hmm. Okay. So it's not as simple as that. What does this do? One thing that does anything, right? Because read six numbers has that type of shit as well. And then at the end, it's just compare with one. So I guess I have to understand what's going on here, maybe. Um, I have to do this plus C, which is which would be what 400F plus C. What is plus C? For it does not to do that. 47 executed, so RCX should have the number that I need. Okay, and then RDX should have the number that I need. Okay, so it's just a bunch of random shit. And then move this into ESI. That's pretty interesting. 4203983. Why did it decide to move that into RSI? And then I'll move 0 to EAX. And then I call this thing and it just fucks everything up. So whatever's happening will be happening in these, right? This changes a lot of things though. Just doesn't seem to be anything. That is in RCX and RDX. But this move instruction, though, is very interesting. I just can't seem to understand, bruh. What is this then? 與上題非常類似。What am I supposed to be feeding it? Yes, I. 403個800 Could it be 403個800? 咪403個800。 Do that. Okay, now I'm in. Okay, cool. Cool, 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 cool. Okay. And now I'm in F6A. RSP kappa. Was een goed wel even die explode wel. bigger than 7. I'm so lost. But right, then E plus A will be DE38. And then you're comparing whatever's in there to 7. But what will be whatever in there though? Is my question. So if I finish calling this, and then I go, it's just very random, my friend. Oh, if it's above, you jump. So I just have to go below, right? Am I retarded here? Right. Okay. Wait. I think I'm getting somewhere. So if I go 10 and 20, right? It is going to bomb after FAD, right? F6F, and then I go to FAD. Boom. Because it's higher than 7. But if I go a number that is smaller than 7, then I should not hit that problem. Right. Boom. So after this, 6F, I jump, but I don't jump. And now I'm going. So I move my first argument to EAX, right? And then it jumps somewhere. And then moves this into EAX. What does jump Q do? That's my question. Absolute address stored at. Oh, it's a jump table? Probably not, right?
With body. Jump. Then we enter the on the stack into
Oh, what the fuck? So all of these address is off by 8, right? Da-na-na-na-na-na-na. Na. Na-na-na-na-na-na-na-na. 71. Let's see. Boom. Well, my first argument. 75 it jumps to where? F8A. Move 100 into EAX. Yeah, so 250, sorry. Like 100 in hex. Next one will be F8F. Oh, jump to F boy E. Compare that with 100. If it's equals, then I exit. So it's 3 and 256, right? Okay, let's try it. Let's see. Hmm? Halfway there. Oh my God, I got it. Okay. Holy shit. Oh my God. Okay. 3 and 256, but it could be other things, I feel. It could be other things, right? Let's say if it's let's say I don't have this, right? Let's say if it's just so it can't be 0, right? I believe. I don't think it can be 0, right? Oh, just hit. Oh, so zero also works. Seven C. So this will be the zero case. This will be the three case. This will be the what case? Wait, no. Wait, what? Seven C. This is the zero case. So it would be zero and what is this? Like XCF in decimal, it would be 207. So if I go 0 and 207, it should work, right? Okay, yeah. So it's 0, 207. And then it's 3 and 256. And then if it's so there should be 1, 0, 1, 2, 3, 4, 5, 6 cases, right? Yeah. 0, 1, 2, 3, 4, 5, 6. Should be 0, 1, 2, 3, 4, 5, 6. I think I'm right. Um, let's see what the guy says. Mhm. 2 and 7 and 7. Okay. I think I'm gonna call it there. Okay. This is actually very, very interesting. Cool. Phase 4, I am kind of scared. I mean, It doesn't look that different, right? Right? Anyways, I'm having a lot of fun doing this. So, and I'm learning a lot about using this stupid fucking debugger piece of shit. Right? So, I am very, very happy about where I am now. Okay, cool. Cool, cool, cool. And I'm very happy with my new laptop. Look at the color. I mean, yeah, the background is kind of fucked, but you know, you understand what I'm saying. Anyways, I will power this off. Oh, by the way, I'm running Linux Mint because it just seems like the easiest to get running. Um, I just want it to work because like I don't want to deal with all the other bullshit like setting up, getting the drivers, getting the hardware going. I just need to work and I just need it for like debugging and shit. So okay, cool. Um, cool. Okay, great. Yep. I think this more than makes up for yesterday's bullshit. So I'm gonna call it here, guys. It's been a long ass day. So peace out. See you tomorrow.